Hi guys, welcome back to my YouTube channel, and in today's video we're going to be going over the 8-step curve sketching process. This is usually taught in the Canadian curriculum, but let me know if it's taught in the other ones as well. So let's get started. Okay guys, so these are the 8 steps in this process. I'll go over each one of them. So the first one is finding the domain of the function, okay? And then the second step is finding the x-intercepts and the y-intercepts. And then the third step is finding the symmetry. So for the symmetry, you want to see if the function is even or odd. So when I'm doing this question, I'll show you guys how to do that. And then the fourth step is finding the asymptotes, the vertical and horizontal asymptotes. And then step 5 is finding where the intervals of increase and decrease are. And then 6, we're finding the local maximum and minimum. I've made a video on all 3 of these. Okay, and then the 7th step is finding the concavity and points of inflection. And the 8th step is graphing it. So let's start with this example, and we'll be doing the steps one by one. Okay guys, so step 1 is really easy because we have a polynomial here and there is nothing that restricts the x. So we can just directly tell that the domain is going to be all real numbers. Negative infinity to positive infinity is going to be the domain. And that's the first step completed. Next is finding intercepts. So let's start on that. Okay guys, so for the intercepts, I don't think I have to explain much because you learned this at a very young age. When you want to find the y-intercept, you put the x as 0 and then you solve. And then for the x-intercept, you put the y as 0 and then you solve the equation. So we got the y-intercept as 0 because when we plugged in 0 into x, it all just turned into 0. So our y-intercept is from 0 to 0, and our x-intercept, you just normally factor and then solve this equation to get what your x values are going to be, and then you get these two intervals for your x-intercepts. Positive root 3 to 0 and negative root 3 to 0. So you have found the third step of symmetry, which is your intercepts. And there you have your 3 intercepts. Okay guys, so here is step 3, and in step 3 you have to find the symmetry. So the symmetry basically just means whether the function is odd or even. And you have to keep 3 things in mind. When you want to find the symmetry, you're going to plug x in as negative. So you're going to substitute all the x's for negative x, and if your functions turn out like this, here's what each of these means. So if f of negative x equals f of x, that means the function is even. Okay, if you plug in the negative x and all of those negatives cancel out and it turns positive, that makes the function even. If you plug in a negative and then the function remains negative, the negatives don't cancel out, that makes it odd. And if the function is neither of these, then that means there's no symmetry in the function. So I will show you guys the symmetry for this one. Okay guys, so here I plugged in the negative x, okay? I plugged in the negative, and now you're going to solve. You know that when you cube a negative, it doesn't turn positive, it stays negative, okay? So the sign has switched from positive here to negative x, okay? And then the second part is when you multiply two negative numbers, they turn positive, okay? That makes this term positive 3x. Now you might be thinking this is neither. It didn't turn all positive nor negative, but that's wrong because when you look up, all the signs have flipped. The first term was positive, except it turned negative here, right? It turned negative. And then the second term, which was negative, it turned positive. So when the signs of the terms flip, that makes it odd because when you plugged in the negative x, it stayed, the whole term turned negative. So that means this function is odd. And there you have step 3 complete, finding the symmetry. One more thing, it'll be easier to visualize it like this. If you take out a common negative, you can see that the whole term has turned into negative f of x. Wait, I think I wrote this wrong. 1 second. Okay guys, sorry, I made a mistake here. I put the negative inside with the x when the whole function is supposed to be negative. So when the whole function turns negative, that makes it odd. And that's exactly what happened here. When you take out the common negative, this is your original equation. But that negative stays, making this whole equation negative, meaning that the symmetry of this is odd. Okay? Okay guys, so step 4 is asymptotes. And asymptotes are basically 1 second, sorry. Guys, sorry, my brother was in the room. Okay. An asymptote is basically a line that approaches but never touches a specific point. So usually you can find them in two ways. The first is vertical asymptotes, and you find these by dividing the fraction by 0. The denominator has to equal to 0. So you are given a fraction like this, 1 over x. When you plug in x as 0, you will get the whole function equivalent to 0 or a separate number. And that would mean that your vertical asymptote is 0 because it turns the whole equation into 0. And the second one is horizontal asymptote. You can check this by looking at the end behavior. They mostly show up in rational fractions like this. Basically, yeah, so they show up in rational functions. And here, when x is approaching infinity, meaning when x gets bigger and bigger, the ratio is approaching 2. Okay, whatever number you put, you can put 10,000 or 10,000 here, and you keep testing the values as they get bigger, you'll see that it's approaching 2. That means the horizontal asymptote is going to be 2. Yeah, so for this function, this is just a polynomial. It's not a fraction, and you can't, like, there's no asymptotes in this. So step 4, we would just say that this function has no asymptotes. I made a mistake when I was explaining 1. When you divide by 0, you won't get 0. It's going to be undefined. That makes it your asymptote. When it turns undefined, that will make it your asymptote. Okay guys, for step 5, it's finding the intervals of increase and decrease. So I already made a video on this. You guys can watch that directly because I'm not going to go into detail. I'm just going to find the answer and explain the steps really quick. So the first step is you take the first derivative of the function, and then you set the derivative equal to 0. You're going to put f prime of x equal to 0, and you're going to find the critical numbers. So you're going to find what x is equal to, and then you're going to put those numbers on a number line and check the intervals in between each critical number. So I'm gonna directly show you guys. Okay guys, so here I went ahead and I directly got the answer. As I said, I followed the steps. You take the first derivative, set it equal to 0, find the critical numbers, which is essentially what x is after using algebra to solve, and then you take that, 1 second. Yeah, you take that critical numbers and you plug them onto a number line. So I got positive and negative 1 because when you square root, you get positive and negative. So I put those on a number line and I use test points like negative 2 or negative 0.5 and positive 2, and I plugged them into the derivative equation, and I got that the intervals are positive, negative, and positive. That means this is going to the left side, right? So the left side indicates that the numbers are getting smaller, making it the interval that from negative infinity to 1, the interval is going to be positive. It's increasing. Negative infinity to negative 1, the interval is increasing. And this interval, negative 1 to positive 1, is decreasing. Okay? It's decreasing here. And from 1 to the right side, which is indicating the number is getting bigger, 1 to infinity is also increasing. So yeah, you just found your intervals of increase and decrease, and that's step 5 solved. Okay guys, so step 6 is finding the local maximum and minimum, and in the number line that I drew like just a clip before, you could see the sign switching from negative, positive, negative, okay? You can see the sign switching. So in my last video when I taught you guys how to find local maximum and minimum, I taught you that when the slope switches from positive to negative, that makes it a local maximum. It's going up and then it's going down. That makes this point a maximum. And that point is when x equals to negative 1. You could clearly see in my number line the sign switching. Okay, if you want to rewind the video, you can go and check. But yeah, the sign at negative 1 went from positive to negative, making negative 1 and local maximum x value. You take the negative 1 and you plug it into the original equation, and then you get the local maximum point. Okay, and then when x equals 1 onto the number line, we could see that it was switching from negative to positive. It goes down, then it goes up, making this a local minimum, okay? So the x value for a local minimum is 1, and then you plug that into the equation, you get the y value, and you have your point for the local minimum. Okay, let's move on to the next one. So step 7 is concavity and points of inflection. I also made a video on this, so I'm not going to go into detail. But what you have to do for this one is very similar to increasing and decreasing intervals. Except the difference is you take the second derivative, you take one derivative, and then you take another derivative, and then you take that equation and you get the critical points and put that on the number line. So here I got the second derivative, which is 6x. We just took the derivative of this twice. Okay, I set this equal to 0 to find the critical point, and I got x equals 0 as the critical point. So I put that on a number line and I checked the intervals. You can use -1, plug the -1 here, you get -6. That makes this interval negative. You can do +1 here, and then 6 times +1 equals +6. That makes this interval positive. So this interval is negative and this is positive. That means this is concave down and this is concave up. And for the point of inflection, I told you guys before that when the sign of the intervals switches from a negative to a positive or from a positive to a negative, that means it's a point of inflection. So here it changed from negative to positive, which means that 0 is the x value of a point of inflection. So you plug that 0 into there, you'll obviously get 0 as the y value. So your point of inflection is 0, 0. Okay, that's the 7th step. Now the 8th step is just graphing it. So I'm going to go ahead and draw the graph. The information that we already gathered from all of the 7 steps should be enough for you to know how to draw the graph. So I'm going to draw it now. So instead of drawing the graph on the whiteboard, I'm just going to put a screenshot on the screen of the information that we found and how we can use that to draw the graph. Okay, you have all of the intercepts, you have the concavity, you have the maximum and minimum values, you have the intercepts, so those can all be used to draw the graph. So I'm gonna put a picture up. Yeah. Okay, guys, so that's it for today's video. Thank you for watching, and I hope the video was helpful. I feel like there are some things that I could have explained better, so if you're having trouble understanding, you can just leave a comment and then I'll make a separate video explaining in detail. So yeah, that's it for today. See you guys next time. Bye.